Hello everybody, this is P. Praveen Kitty. I'm going to deliver a lecture on reflection. I hope you are all in good health. Let's pray all this coronavirus pandemic ends soon. I sincerely hope that the situation in the world will improve soon. Take care of yourselves, family, and stay healthy. I request everybody to please stay home and stay safe. So let's go to the class now. Now we're going to deal about reflection. Consider a two-way transmission line. Here Zn is called input impedance and Z0 is called characteristic impedance and Zr is called load impedance at the receiving end. Okay, so Zn is input impedance and Z0 is characteristic impedance. So here Zn is equal to Z0 and Zr is load impedance at the receiving end. So when Z0 is equal to Zr, that is Zn is equal to Zr, then reflection does not occur. That means impedance matches. So whatever the data which we send from the sending end will be received at the receiving end and the reflection does not occur. If at all the input impedance is not equal to the load impedance at the receiving end, then reflection occurs. That means the data is not sent perfectly to the receiving end. Reflection is defined as the reflected wave which is occurred at the load or receiving end due to improper termination or due to impedance irregularity in a transmission line. So here improper termination or impedance irregularity both means the same. That means Z in the input impedance is not equal to load impedance. When a wave is sent from the sending end to the receiving end in a transmission line which is having improper termination, that means Zr not equal to Z0, then reflected wave is present. Here the generated reflected wave goes to the sending end and this reflected wave which is at the sending end becomes an incident wave. So the reflected wave becomes an incident wave and again it goes to the receiving end and again it comes back again to the sending end. So and this process will goes on. So the energy is thus transmitted back and forth on the line and there will be a lot of losses on the line. The reflection will be maximum when the line is open or short circuited and will be zero when Zr is equal to Z0. If a line is open circuited, IR is equal to 0. It means Zr is equal to infinity. So we know that Zr is equal to VR by IR. If IR is equal to 0 means Zr is equal to infinity. So here Zr is not equal to Zn, it is not perfectly matched, so reflection will be maximum. If the line is short circuited, VR is equal to 0. Zr is equal to VR by IR. Okay. So if VR is equal to 0 means Zr is equal to 0. So again it is Zin is not equal to Zr. So it is not perfectly matched. So reflection will be maximum. If Zr is equal to Z0, which is equal to the input impedance or characteristic impedance, then all the data which is sent from the sending end will be received at the receiving end. So the reflection will be 0. There is no reflection.